All right, can you guys all hear me?
Yeah, we can hear you and we can also see your slide.
Okay. All right, hi everyone. My name's Amal Gatima. I'm presenting on behalf of Group 11, and our topic is on PCA. So what is PCA? PCA is essentially a dimensionality or reduction technique, essentially taking a data set that's in high rank or has many features and transforming it down to a low rank with K number of features, which is much smaller. And these features are called, or this rank is called principal components, and they're often independent and uncorrelated. The whole point of PCA is to really allow for better visualization. So in like a 2D space or a 3D space that a human can understand, and also for various ML applications. So in terms of the theory for PCA, we're essentially trying to find a direction vector U that maximizes the total variance of the original data set. So U contains an X number of PCs, each a linear combination of the original features, and you're trying to maximize that original explained variance. The process for this is essentially you find a covariance matrix, and then you conduct some sort of singular value decomposition, and then you take the top K eigenvectors and eigenvalues that maximizes that variance. Another important concept is this idea of PCA loadings. So as I said before, each principal component is a linear combination of the original features. So each feature has a number associated with it, and that just explains how important it is to that particular principal component. So like I said before, we are using the Swiss dataset to perform PCA. This Swiss dataset has 47 observations, which represent 47 provinces of Switzerland. And we have 6 features, including fertility, agriculture, examination, education, Catholic, and infant mortality. So here's our implementation of how we used the code to implement PCA. The first step was to scale the data because a lot of the features were not in the same scale. So it's important to do that before we run PR comp. And here was our proportion of variance graph. You can see that PC1 has 53% of explained variance, so that one has the largest variance explained. And as we mentioned in class, around 80% of variance should be explained for it to be the ideal number of PCs. So based off the screen plot, you can see that around 2 to 3 PCs are most optimal for this data set. And that also helps us achieve that 80% explained variance. So here are the loadings that we had for each PC. We chose 3 principal components. And as we had 6 features in the data set, we wanted to see if there was some sort of themes or some sort of theme that we could kind of attach instead of having these 6 individual features. And if we look at the loadings, PC3 has a large loading value of 0.8 for Catholic. And that's the largest one in that group, which kind of leads us to believe that PC3 may be informing us about the culture or religion of the region. In similar ways, PC2 may be informing us about public health, and PC1 is about the socioeconomic status of the region. So for comparison measures, we also learned about sparse PCA in class, which is another method um, for PCA. However, it tends to provide more interpretability, but also explains a lower explained variance. So we want to see how that worked in our data set. So we ran sparse PCA in R, and right away we can see that the percentage of explained variance is much lower. You can see that it's cumulatively around like 50%, whereas standard PCA was 80% or higher. However, if you look at the loadings down here, you can see that it's much more interpretable. PC1 is heavily guided by examination, PC3 is guided by Catholic, and it leads us to kind of the interpretations are the same as our standard PCA. But I guess the point with the slide was to really show that although sparse PCA is interpretable, it does have very low variance. So if we were able to introduce more data into the data set, it may not be the best model for visualization purposes. So in conclusion, standard PCA favors capturing maximum variance over interpretability. And for our data set, we thought that 3 PCs were optimal to capture like the socioeconomic, public health, and cultural factors of a region. In terms of improvements, we thought that it would be good to try another data set with more features in the future, just to see how sparse PCA and standard PCA can be distinguished. But that's all that we have. Any questions?
Can we give the presenter a round of applause? Presenter only used 4 minutes. 4 minutes with an excellent presentation. Okay, so I actually this is a question time. In case before I make my remark. So is there anyone in the among the audience that may want to ask one or two questions? Is there anyone? I want to ask one or two questions among the audience. Okay, so in the absence of question, but before that, I'm still seeing 4 students that are not putting on their video. I only approve 1 student because of medical reason, but I'm still seeing 4 students who are not putting on their video. Like I said, I'm writing the attendance of those who put on the video. If you don't put on your video, there's no way I'm going to write it down. I'm not going to, it means you didn't participate, except for those who have written me, about having medical appointment. Okay, so want to appreciate the presenter, for actually doing a very great job. I think I'm really impressed with the way you compare the standard PCA and the sparse PCA. And of course, at the end of the day, I can see that when it comes to loading, okay, there is agreement between the two. So I'm actually going to advise whoever that is working on PCA to also consider sparse PCA. Okay, if you are working on sparse PCA, yeah, you also need to consider the standard PCA. So the two of them are actually connected. And I love, I think you mentioned in your presentation, you know, what the benefit is, using the conventional PCA, and what the benefit is using the sparse PCA, and what the weakness is. So that's highly commendable. So I don't think I have anything to add, to that presentation. So that was so very, very clear to me. Okay, so group 11, thanks for doing a great job. Is group 12 ready? Is group 12 ready?
Yes.
Okay, group 12, you got the floor. You can share your screen now. You got 5 minutes.
Okay. Um, can you guys see my screen right now?
Yeah, I can see your screen on factor analysis. Yep.
Okay. So, hi everyone, my name is Cheryl and this is Group 12's presentation. Today we're going to talk about a factor analysis of global happiness. And today's presentation will include 4 parts, which are introduction, implementation, result and evaluation, and the conclusion. Let's get into the introduction part. I want to talk about what is factor analysis first. So it is a dimensionality reduction technique by extracting latent factors to explore hidden patterns in the data. And the data will be 2021 World Happiness Report, and we will focus on 2 main questions. First, what are the underlying factors of global happiness? And second, how do these factors help us improve the happiness level? Let's get into the implementation part. So we have 6 variables in the dataset, which are locked GDP per person, social support, healthy life expectancy, freedom to make life choices, generosity, and perceptions of corruption. Each of the variables' meaning is listed here. For the factor analysis process, we have 3 steps. First, we deal with the data. We extracted those 6 numerical data from the data set, and then we scaled them since they have different units. And second, we applied factor analysis with 2 and 3 factors, and we visualized the result in the final step. I want to talk about the second step, why we choose 2 factors instead of 3. We have 2 criteria. First, according to the loading table, we can see that 2 factors explain around 59% of the total variance, while the 3 factor only explained around 65% of the total variance. We want to balance the interpretability and simplicity. So, since they don't have a huge difference, we chose 2 factors. And also, we generated a screen plot, which shows that 2 factors is the album point. So, based on 2 criteria, we chose 2 factors and then we visualize our result. We can see that the first factor has a high positive relationship with the log GDP per person, healthy life expectancy, social support, and perceptions of corruption, and we interpreted it as the material dimensions of well-being. Meanwhile, the second factor has high positive relationship with freedom to make life choices and generosity, so we interpret it as the spiritual dimensions of well-being. For the alternative evaluation, we also applied principal component analysis to the same dataset, and we used the correlation metrics. We see that the first 3 principal components explain around 85% of the total variance. After comparing those 2 methods, we found that even though principal component analysis explained more variances, we still prefer factor analysis since 2 reasons. First, in factor analysis, we don't have to introduce new variables. We can only translate the old variables as linear functions of the factors, which makes it more elaborate. Second, in factor analysis, each variable contributes to only one component instead of contributing to more than one component, which makes it more interpretable. Based on those 2 advantages, we prefer factor analysis rather than principal component analysis. Let's discuss our conclusion. I want to go back to our research topics. For the first one, what are the underlying factors? We found 2 factors, which are the material dimensions of well-being and the spiritual dimensions of well-being. For the second question, how do these factors help us to improve the happiness level? According to the first factor, we can improve the material levels like have a higher income, better health care, or less corruptions. According to the second factor, we can also improve the spiritual levels. For example, devote ourselves to the charitable work or make more life choices. In the end, I want to talk about the limitations and further improvements. Now we only have 6 variables, which is not that diverse, so we could contain probably more variables in the future. And now we only applied factor analysis, which means we could use virus method. And the second limitation is some variables are ambiguous, so maybe we could have better conceptual insights of those variables. That's all for our presentation today. Thank you, and any questions?
Okay, so can we give this presenter a round of applause, for having a wonderful presentation. Um, this is a question time. So, is there anyone who want to ask question?
I have 2 questions.
Okay, so go ahead.
The first is with the 2 factors you found, like one representing like the material, uh, factors in happiness, and like the second one being spiritual. Did you find that at all surprising, or is that kind of what you expected? And then the second question would be, I know you guys didn't include the third factor, but did you guys look at that maybe on the side, like before you threw it out, or if not, would you have sort of a guess to what that third factor would represent in terms of contributing to happiness?
Okay, so
Sorry,
did you get it?
can you maybe
Yeah, I can repeat.
simplify your question?
Yeah, okay, so the first one is, were you surprised by what the two factors represented? Like, did you expect it to kind of be like, oh, like before going into it, like maybe like material and spiritual like contribute to happiness, or was it kind of just what you expected? That's the first one.
So it has whether you were surprised about the two factors. Were you really surprised? Was that part of your expectation? Did
Oh,
you did,
sorry.
did you get that?
Yes. Sorry. What does the price mean?
Yeah, surprised like were
Oh,
you surprised to see that those are the significant factors? What or did you get that?
yes. Okay. So, actually, we are not that surprised about that because I think in our like the tuition level, we kind of also measure the happiness level to be divided into the material part and the spiritual part. And as you can see in this plot, um, it kind of fit in our tuition that factor one is the economic and health foundations, and it represents the material dimensions. And factor two is the autonomy and generosity, which represent the spiritual dimensions. So we're not surprised to see this result, and I think this result definitely makes sense to us.
Okay,
Okay.
and then with the other one, I'll just simplify it more. Um, would you have a guess to what the third factor would be? Like the one that you guys didn't use? Do you think it would just be like a mix between the two, or
Oh, so you mean the third factor?
yeah, that you guys like didn't include because of like
Okay, so yeah, actually, we also visualized that result and we found that if we divided the variable into three factors, then the third factor will be only the generosity, which
okay,
means, yeah, which means we kind of have the second factor only conclude the freedom to make life choices, and then we separate the generosity into the third factor. But I don't think it is that meaningful because we can just include both freedom and generosity into the spiritual dimensions. So I think that make more sense.
okay, that makes sense. Thank you.
Yeah, thank you for asking.
No problem.
Yeah, thank you for that question and thanks for the excellent response. Um, the only question I want to ask, like, what is the number of features, like the numbers of variables you have initially? I believe you extracted hidden factors, but how many variables do you have initially?
Yeah, so actually we have I think five more variables initially, and when we do the data cleaning, there is kind of like a ladder factor in the beginning as a column. So the reason why we get rid of it is because we think the ladder factor is a measurement based on all those six numerical factors. And that is kind of like not the same level with those six basic variables. So, and also in the data set, it measures the upper level, like the upper bound, the lower bound, and the mean and the variance of the latent factors. So we kind of get rid of those and we only want to measure the six basic variables because that make more sense.
Okay, so if you say six basic variables, are you referring to lag GDP, Earth life, expectancy, social support? Is that what you mean by the variables?
Yes, so actually when we generated the meaning of those variables, we we take a look at the original report and then we find each variable's meaning and how they measure those variables. And we found that those six variables are taken by some survey or some interview. And the latter factor is that the author generated it based on those six variables. So that's why we have only those 6 variables here.
Okay, Group 12, you've done a fantastic job with X coupled with excellent presentation. Thank you so much. I don't think I have any uh, you know, comments, to make at this junction. So thank you. So you can stop the share.
Thank you.
You're welcome. Okay, so group 13, are you ready? It's your turn, group 13.
Yep.
Okay, can share your screen. Want to listen to you. You got 5 minutes.
Okay, can you see my screen?
Yeah, we can see
Oh,
your screen.
okay. Hi, I'm Luke Robertson, and I am presenting on behalf of Group 13. And so we also worked with factor analysis, but we did it on a personality data set. And so first of all, we're going to talk about factor analysis here. And so factors are underlying attributes that explain the covariation in just in a data set. And so there's a bit of a visualization here of that. You have latent factors, and they explain the covariation among variables here. And so, but these are not directly observable, and so we have to use factor analysis to figure them out. And so it also helps uncover patterns and structures in the data, and it can give you more interpretability compared to individual analysis of variables. And so this is very useful in psychology where there are inherent latent characteristics that like come with data sets. And so how does it work? So the main equation here is here, and so you have this term, which is the loadings, and that's for J on factor K. And then you also have the factor for however many K factors that you choose. And then you also have an error term, and that gives you the full model. And so what you get from here is a matrix of factor loadings that will show associations between the factors and their variables. And so what else happens here is that the eigenvalues represent the variance that is explained by each factor. And so that'll show you the variance explained by each factor that will give you the opportunity to choose the amount of factors. And the total variance explained by one factor is the squared sum of the factor loadings, which is represented by this term, which is the squared loading of J on K. And so the data set that we used came from Kaggle, and it's the Big Five personality test that came from Kaggle. Another thing that this is called is the five-factor model or the ocean model. And so after we did some data filtering, there ended up being 350,000 samples from the United States. And so we only worked with the United States just to have some sort of uniformity in there. And so the theory is that factor analysis should correctly group the 50 questions into their respective categories. And so the idea is that these 50 questions are each 50 different variables that should fit into 5 different factors. And the categories, which are 5 different aspects to personality, are extroversion, agreeableness, conscientiousness, emotional stability, and then intellect/imagination, which can also be known as like openness. And so the first thing that we did was we looked at how feasible it was to perform factor analysis on the data set. And so there are different methods to do that. One of them is Bartlett's chi-squared test. And after doing that, we found that the p-value there is less than 0.05. And so we conclude that there are enough correlations to perform factor analysis on this data. There's also the Kaiser-Meyer-Olkin measure. And we also found that that had a value above 0.9, which indicates that it is suitable for factor analysis. And then we wanted to find out what the optimal number of factors are. And so we used both the Elbow method and the Kaiser criterion. And so looking at this scree plot here, you can see that the elbow is around 6 factors. And so the disadvantage is that this can sometimes be subjective. And so that is why the Kaiser criterion also exists. And so you want to keep factors with an eigenvalue greater than 1. And so that leads to 8 factors, as you can see here with this line. And so that removes the subjectivity, but it also gives us more factors in this case. And so when we visualize it with 6 factors, you can see, which is what we selected for the elbow method, you can see that there's almost perfect clustering except for uh, extrovertedness and agreeableness. Uh, well, extrovertedness and agreeableness seem to relate to each other, as you can see here. And then also, factor 5 and 6 is split for openness. And then when we move to 8 factors, the 7th and 8th factors do not really have a good interpretation at all, and they don't belong to any question group. And you can also see that 5 and 6 are related and cover the openness questions. And the first 4 factors are also consistent to how they were with 6 factors. And so then we looked at the 5 factors, which was based on domain knowledge. And so you can see that here they align perfectly. You can see the correlations between all the groups are good here. And so extrovertedness and agreeableness appear to relate to each other as well, as you can see. And this makes sense from a psychological standpoint as they tend to go together. And so basically the 5 factor solution here, it will remove excess factors using domain knowledge that do not have a quality interpretation. And so this appears to have the best interpretation. And so if we're looking at the discussion here, picking the correct number of factors is very important to analyze complex data sets such as this one. If you don't have enough factors, it oversimplifies the data, and if you have too many factors, it overfits the data. The traditional methods, such as the Kaiser criterion and the Elbow method, can suggest a different number of factors, which make it subjective. And so that's where domain knowledge becomes critical to determining the number of factors because it will ensure that they align with theoretical constructs. And it's also needed for meaningful interpretation, for example, here, so they can fit the 5 aspects of personality. And so, to summarize, the goal was to confirm that the questions align with the specific personality dimensions. And so the result is that the data does support that they do support the 5 personality dimensions, and that 5 factors was the best fit for this data set. And also, what they showed is that this test is a good test for those personality factors, and that this test that's being given is fitting for what it wants to do because it aligns with the 5 factors. And so with that, are there any questions?
Okay, so can we give the presenter a round of applause, please? Thank you for wonderful presentation. Is there any question? Any question? I think I'm going to say this. This particular group actually brought uniqueness into presentation. And I want every other group that I've presented to learn something from this group. I actually like the presentation because the group started by specifying the model. Not only that, they specify the model, the group explain every term, every notation in the model. Because if we want to, conduct, want to actually, you want to do research, statistical or machine learning research, we normally, want the audience, to understand the model, the algorithm we're using, and of course, this particular group actually explain that. Not only that, this particular group also tested assumptions. Every model, anywhere in the world, as assumption. A model is good. What make a model to be valid is when assumption hold. So this particular group went ahead, to explain, the necessary assumptions needed, and they tested and they realized that, oh, we can move forward. Then before now go into analysis. Okay, so I'm actually commending this group. Okay, every other group has done very great job too, but the uniqueness here is the explanation of the model. Okay, every notation in the model and testing the assumptions underlying, the use of, the model. So excellent presentation. Okay, I got no remark at this time than to commend the presenter and everyone in the group that have done a great job. Okay, so you can stop your share. Thanks for the excellent presentation. Uh, I'm actually going to group 14. Is group 14 ready?
Yeah, let me just share my screen.
Okay, go ahead, group 14. Share your screen. You got 5 minutes.
Right. Hi, I'm Shreyas, representing Group 14, and today we're going to be exploring sparse PCA. Sparse PCA has its roots in PCA, which was invented by Carl Pearson in 1901 and later independently developed and named by Harold Hotelling in the 1930s. Sparse PCA was developed and refined by various researchers, so we're going to discuss just a few of them. Jolliffe et al. Imposed an L1 penalty on PCA to achieve sparsity and introduced the idea of sparse loadings in PCA. Zhou et al. Developed the sparse PCA criterion, which allowed for different penalization parameters for each component and formalizing sparse PCA using the elastic net framework and improving sparsity. But what is sparse PCA? The focus of sparse PCA is dimensionality reduction. The focus of PCA is dimensionality reduction, but this often sacrifices interpretation as they involve contributions from all features, which can lead to overfitting or irrelevant variables. Sparse PCA incorporates sparsity constraints to force extraneous loadings within principal components to shrink to zero and produce principal components that rely on a smaller subset, allowing users to identify features that are the most important, thus increasing interpretability at the cost of some optimality. Sparse PCA does not have a specific formula, as different purposes call for varying levels of regularization and sparsity constraints. For analysis in this presentation, we will be using one of the most commonly used formalizations, the elastic net sparse PCA. It's defined as convex and by a parameter penalty characterized by L1 sparsity enforcement to reduce small coefficients to zero, and a robustness mechanism through an L2 penalty, which shrinks all coefficients. We applied PCA and sparse PCA techniques to 3 different datasets. MT-CARS is the dataset that was extracted from 1974 Motor Trend magazine and provides specifications and performance characteristics of cars. The iris dataset contains information on 3 different species of iris flowers and has 5 variables for each flower. Since we were using this dataset to explore sparse PCA, we chose to only use 4 variables. The final dataset we explore is US arrests. Each observation in this dataset is in a state within the United States and has 4 variables. We ran the PCA on MT-CARS using the correlation matrix, considering the variables mentioned above are in different units. The first principal component of PCA and sparse PCA are very similar, as a smaller penalty parameter of 0.1 was used. You can see how many of the later principals components are much more reduced. The trade-off in explained variance is also somewhat small here, only being 84 versus 82% for the first 2 principal components. Having enforced sparsity in the loadings of each principal component makes results more interpretable, but sacrifices the total variance covered by the selected amount of principal components. In this figure, we see a bit plot with PC1 on the x-axis and PC2 on the y-axis, showing where observations appear in the principal component space. The location of the observations in the biplot also shows that the way data points are clustered is consistent with expectations, as similar cars such as a Toyota Corolla and a Honda Civic are found in close proximity. The PCA and sparse PCA in the iris data are very similar, but sparse PCA drags some values down to 0 when it deems them inconsequentially small. This helps the interpretability of the model because you have less variables to look at and interpret. Both methods do agree on how many principal components to use. 2. You can clearly get 96% of your variance explained through PC1 and PC2, and the elbow rule gives us 2 components from sparse PCA. The slight trade-off between PCA and sparse PCA can be seen here, as sparse PCA's first 2 principal components explain less of the variance. We ran the PCA on the US arrest dataset using the covariance matrix because most, if not all, the variables are in the same unit. We see very similar results using this data set. Sparse PCA results in more zeros and ones in the principal components and cuts down the variables we need to look at in the first principal component by making it much more comprehensive and interpretable. Naturally, the difference in the variance explained with the first two principal components is larger, with standard PCA explaining 99.9% and sparse PCA only explaining 84%. In conclusion, the loadings pushed to zero by the penalty parameter helped the interpretability of our sparse PCA models, but subsequent limited explained variance of varying degrees among datasets gave us a look at how interpretability may sacrifice variance explanation in some datasets more than others, even with a good choice of penalty parameter. The influence of the penalty parameter was also very apparent, with low values having little impact and higher values sacrificing much more explained variance. That's all we have. Any questions?
Okay, so can we also appreciate the presenter and group 14? Okay, so any question? Is there any question? Okay, so I think this group also they follow the pattern of group 13 because I saw the presenter. Please, I need you to mute because I'm hearing myself. Okay, everyone should mute. Thank you so much. Okay, so I'm trying to say that this group also, they're working on sparse PCA, and the presenter was able to explain the model. You talk about the penalty because what we make our presentation to be different from those in psychology, those in sociology, those outside statistical machine learning is when we're trying to explain the terminology or the notations in our model because our models scare a lot of people. So our models and algorithms scare a lot of people. So I think they're gonna be happy, when they see that we are actually explaining everything behind the notation. So this is an excellent work. The question I want to ask from this presenter, can you a little bit go back to the result of your analysis? Can you go back to the result? Is the presenter hearing me?
Yeah, I can hear you. Let me see if I can
Okay,
go back.
okay, so I want to go back to the result of the analysis where the result
One
of this
second.
past PCA.
Sure, we had three different data sets. Which one do you
Okay,
want me to?
the one on the sparse, let me see. Maybe you can keep going. There was one I saw -1 on the sparse PCA. I saw -1 and 1. So
Let me
you
see.
can, yeah, here, yeah. If you look at PC2, right? Actually referring to the sparse. So the PC2 has a -1 on separ weight, right? Can you see what I'm talking about, right?
Yeah,
Okay, so having a -1 on separ weight, so what is the implication of that? Like practically, let's say I'm not in statistics or I'm not in machine learning. Maybe somebody in psychology or somebody in sociology was trying to ask, well, what is the significance? Well, what is that -1 telling us?
right.
You can
So,
you can respond to that, or any member of your group can also respond to that. So if you like,
uh, did anyone else want to respond to you? Should I go ahead?
yeah. So
Okay.
whoever,
No,
whether
I'm
you,
just asking. Okay. All right.
yeah, yeah.
So, um, basically the way we would interpret this is that we have sepal width is negatively correlated with other variables that we have here, such as length, sepal length, petal length, and petal width. That's how I would explain it to any sociology or other
Okay,
major.
okay. So the only remark here is make sure that you understand how to interpret, every, um, value that came out from analysis, not only for this group, but for all groups. Okay, so I want to have a general remark now, and I actually give kudos, Group 14, you've done a very great job. So can you stop your share? Because I have a remark that I just want to pass across. Okay, so let me say this. I actually want to take this moment, to commend you all, okay, on the outstanding quality of your presentations. You know, let me say this, you didn't find yourself, doing wonderful job by accident. I'm never going to call this an accidental discharge of nature, but I'm going to say your hard work, depth of analysis and your innovative approaches, your collaboration, were actually, truly impressive, to me. I can see, it is evident that you've actually put in significant efforts, and dedication, for you to produce the excellent work. And let me just say this, given the quality of your project, I will strongly encourage you to consider refining your papers. Don't forget, you have a deadline, right? To submit your final report. Okay. And I will also tell you this. I can boastfully say that this class is one of my best class ever. Okay, if I want to talk about my class, the class that I taught in Africa, the class that I taught in Europe, and the class that I taught in the United States, this class stand out. I can boastfully say that anywhere in the world. And I'm going to say this, given the quality of your project, I will strongly encourage you to, consider refining your papers and submitting them to top journals. Okay, top journals in your respective field, top journal in the United States, top journal anywhere in the world. Okay, you know, uh, that is gonna, this is a kind of a great opportunity, to showcase your research and contribute, to broader academic community. The presentation you're making, the work you've done, I also want the world to benefit, from it. And what I'm going to say at this time is that, you need to keep up the fantastic work and don't hesitate to reach out, if you need guidance or support, in preparing your papers for submission. So, but there's something I also, if you want to improve um the quality of your work, okay, there's something that we can actually um you know that I want to talk about. Number one thing that you're going to talk about is make sure you clearly define your topic. Topic is very, very important. Your objective, okay, the method, the model, very important. Okay, the model, and of course, make sure you have a kind of description of what each symbol notation in your model represent, because that is what scared the world about statistics and machine learning. I used to tell everybody now around me, the most simplest subject on earth is statistics and machine and data science. The most simplest subject on earth. Anything mathematically related. But what scare people, what really make a subject not attractive at time is because of the fact that we don't normally, explain the reason behind or let me just say the meaning of the notation in our module and the reason behind the notation. The moment the outside world understand what those notations stand for, oh my God, they will appreciate our work. Statistics as a field, machine learning, the data science and so general will be very attractive to the world. So I'm going to say I'm proud of every group members from group 1 to group 14 because your presentation actually showcase the fact that you've worked together, you are highly dedicated, and you can now begin to go to conferences. You can, the way you present, yeah, I even though I know it may take you more than 5 minutes to make this presentation, some of you even present within 4 minutes, and what you said makes sense. If you go to any conference, whether you want to go to ASA conference or MAA conference or any top conference in the world, of course, um, they are not going to regret listening to you. Okay, so once again, I want to congratulate because I'm confirming to you from group number 1 to group number 14 for your presentation. Okay, your presentation is A, except that some group we have more A's than the other. But you all have A's for presentation. But the only thing I'm waiting for right now, I'm actually waiting for your report because I'm also going to grade your report. I've graded I'm done grading your presentation. Okay, you all have A's, but with different grades. You're going to see, I'm going to share the grade with you very soon when your report is in. You need to go back to the work, do some refine the work, make use of the remarks, the question, incorporate that, I mentioned something that has to do with model, very important. When you're working with any statistical or machine learning model, you have to have that in display, and you need to like what does a particular notation or symbol stand for in your model. Okay, so aside that, I think I'm kind of pleased with you with your presentation, and I actually have this hope that I'm gonna have my party. Because with the way what I'm saying now, the party is gonna take place. So I'm gonna notify you. But I four of us want you to finish. I want you to finish your exam. I want you to fully concentrate on your final. Okay, and after that, then I'm actually gonna have my party. So I'm gonna let you know about my party. But there's something I'm gonna say before I go. If there is any group presenter, because I have it in mind to publish. I mean, sorry, to publish this video on YouTube. But if there is a particular group that is not that doesn't want to go to public, like if you have a concern, about me publishing you, okay, on YouTube, please reach out. Because the reason why I want to do that, you all have excellent presentation. Any statistical audience, any research audience listening to you, they're actually going to benefit a lot. Okay, but if you have concern about me putting your presentation on YouTube, please reach out. Okay, in fact, I want every presenter to reach out. Okay, if you want me to publish your presentation, because the way I'm going to do it, I'm going to split the presentation to 14. Okay, for it has to be a group specific. So if you don't want your presentation, if you want me to publish your presentation on YouTube, then you're going to write me and say, okay, yes, I want that. If you don't want it, say, no, I don't want that. And I'm going to respect that. Aside that, we are resuming in person teaching on Monday. I told you the other time, if I see only one person that said in-person class, we're returning to in-person class. And of course, our exam is very close. The final exam is very close. So before Monday, I'm going to release final exam practice question. I still have one more topic, which is going to be, I'm going to achieve that in one class, and the remaining class will be targeted toward revision. Like I said, uh, this very class is an excellent class based on what I've been seeing. This very class can compete favorably with any top university in the whole world. I can boastfully say that when it comes to statistical machine learning, you stand out. Okay, aside that, is there anybody who want to say something before we go? Is there
Um,
anybody? Go ahead.
I have a question. So for the uh presentation slides, the limitation pages for it is 10 to 15, but like our group has like more than 15. Is it okay for the final slide?
Okay, so because I know there's going to be a lot that will be in the report. Okay, so I can actually increase the number of pages in the report to 20 because
Oh,
we
okay.
the
So the report and the slides is separate. So you will only grade the report, not for the presentation slides.
okay, I've already graded presentation slide. I told you
Okay.
I graded everything. I graded your presentation. I also
Oh,
graded when you presented your work, and I also graded your paper. The next thing for me to grade now is your final report. Your final report is expected to be refined. What do I mean by refine? Improve on the quality, by incorporating my remarks, the question asked, and so on like that. Does that make sense to you now?
yeah, yeah.
Okay.
Yeah, got you. So we don't have like the word limitation for the